Okay, we're going to work on the springs inquiry, and you need to open up this applet. We're going to be using spring 1 here. If you have a little start line right here that we can measure things from, and we're going to make sure that that's kind of lined up right there in line with that first spring. We're only going to use spring 1. You can take your ruler and you can put it down right there at the start of that start line so we can measure some certain things. We have friction on. We're going to be on the earth right now. In this applet, you can also use spring 3, and you actually can change the K value of it, but we're not going to do that for this applet. I have several different masses. I put them on here. You'll see that there's some sound, so we don't really want the sound, so we're going to turn the sound off for this. Okay, if you look at the inquiry, we're going to do part 1 in this video, and it says to use spring 1 in the known masses, record some data, and then graph the data in Excel. So the slope of the best fit line will give you the spring constant, K, in newtons per meter. Okay, so what we want is we want an Excel page up, a workbook, and I have one here called Spring Inquiry. We're going to try to do part 1. And so in part 1, we're going to use the different masses on spring 1 and try to figure out what a K value is. And if you remember, Hooke's law is F equals K times D. So this is obviously already in slope-intercept form, like y equals mx. So if we can graph force on the y-axis and displacement on the x-axis, then the slope of our line should be our K value. So if you remember, we need x first and then y. So x is going to be d, and our y is going to be force. And we have a whole bunch of masses. We have a 50 mass, we have a 100 mass, and we have a 250 mass object. So how much force, when we hang these things on the spring 1, how much force is it going to be? Well, I need to turn these to kilograms and then multiply by 9.81 to get the force. So in this one, I'm going to write an equation equals, I'm going to take the mass, and that's in grams, so we want to divide that by 1,000 to put it in kilograms. And then we want to multiply by 9.81 to put it into newtons. Then I can take that and drag that equation down. So those will be our forces that we're going to put on the spring, and then we want to measure how far it'll displace it. So if I go into here and I take the 50 gram mass and I try to put it on here, and it's going to pull it down a little bit, and I can kind of click on it until it stops moving, and that looks like it's about 5 centimeters. So we'll go back to here, and then for this displacement we'll put 0.05. We'll go ahead and put that in meters, is what it should be in. We'll come back and we'll get the 100. Grab the 100, put it on here. And it looks to be around 10. So we'll put 0.10 in for that. Come back here, get the 250. And it looks like 24.9 maybe, 24.9. So 0.249 meters. And so now we have displacement, we have force. So if I graph these, I should hopefully get a straight line. So I'm going to highlight those. I'll come up to Insert, come here to the scatter plot, get the scatter with smooth lines, and it looks pretty good. Come in here and just change the chart title to Force versus Displacement. Click on the chart, add chart element. We'll come to trend line, more trend line options. And then we want linear. We do want an R² value, see how straight it is, and this comes out really, really good. We want the equation on the chart, which will give us a slope. We're going to go ahead and set the intercept to 0. So it gives us a K value of 9.843. 9.843. So I'll kind of shrink that down, put it up here, and then down here in part 1 I'll do K equals 9.8428. And I'll put that over there and put that over there. So there's our K value, and we'll be able to use that for the rest of the parts. So that's part 1. We used force and displacement to calculate the K value by finding the slope of the line. That's the end of video part 1.